Have questions on 1, 2, or 3? Finding the x-intercepts. Okay, those are pretty quick problems that don't require a lot of work. Students will be able to graph inequalities linear this time. You should have these memorized by now, but we will jot them one more time. When you're asked to graph a linear inequality, this looks oddly similar to something. Silent hand if you notice something that it looks a lot like Colby. It looks a ton like your slope-intercept form, and it basically is. The only difference is that inequality. We're going to start out exactly like you would graph an inequality or a equation in slope-intercept form. There's your slope. There's your y-intercepts. Go ahead and graph it. Question, Wyatt? Not inequalities, you're thinking of something else, but you'll see. Yeah. If you, actually, let's pause here. If you see something that looks like this, 3x minus 4, give me a scale of 1 to 5. 5, I could graph that right now. 3, I need a refresher. 1, I like never learned that, and I need help. Okay, cool. Andrew, where you at? I need to see something. Cool. All right, hands down. When you have an equation like this, you're going to start at the y-intercept, and you're going to put the dot there. That's your starting point, so you have some place to go off of for your slope. The slope value is 3, and slope is always written in rise over run. The only problem is the 3 doesn't have anything for the run. What can I always place underneath a whole number to make it a fraction? Whole class, a 1. So that's going to go up 3 and over 1 from this spot. So let's go ahead and do that. Up 3, over 1. Up 3, over 1. Up 3, over 1. Once you have 2 or 3 lines, you can make, or dots, you can make a line. During independent practice, I will pass out rulers for you. That's a positive slope, and you know it's positive because slope man can only walk left to right. Do you guys remember this from last year if you're in my class? And if it's positive, it has to be going up, so he can't go back left. And the top hat's courtesy of Carolyn. Sure. There's slope man, he's going up, it's positive. So that's basically the same exact thing that you did last year. Here's the difference. When you have an x value that is 1, let's just play around with this and see what x equals 1 would look like. Y is greater than or equal to 3 times 1 minus 4. When x is 1, y has to be greater than negative 1. So all of these values for y when x is 1 have to be greater than y is negative 1. So everything up here could work. Let's try another one. Let's try x equals, let's go with 3. If x equals 3, what's the y going to have to be bigger than? Plug that in for me, and what do you get for that one, Sarah? Let's see if that matches the graph. When the x is 3, 1, 2, 3, 4, 5, y has to be bigger than 5. So what you just found out was in an inequality, normally the points are only the ones on the graph, but the things that will make it a solution are anything above this line. Every point in this shaded area will work. The pink is obnoxious. Let me use like a light gray. Do I have a light gray? I do. I know. I should explore. Question, Jordan. Sure. So yeah, good question. So if you go like this and extend the line, we should probably get in the habit of like doing it till it's off the graph. You could basically make it work for anything down here. Okay, so anything above this line will work. Above the line will work. If you're ever confused as to what's above and what's below, choose a point on the line and plug it in to see what it's greater than, and that'll show you the direction that it goes. Sure. You can shade it. Since the ordered pairs are on the upper side of the line, shade over it to represent the location of your solutions. So you're basically going to have a graph that looks just lightly shaded with your pencil on one side of this for your answer. What does that mean? We'll look more into it in this one, but that's how you graph it. Go ahead and graph y is less than 2x plus 3. Give me the starting point, Vienna. Y is less than 2x plus 3. Where do I start? Yeah, the 2 over 1, sure. And then where do I start to graph it? Where's the y-intercept? Okay. Do not draw the line yet. Don't go ahead of me for this one. From the 3, do the slope Vienna up 2 and over 1, up 2 over 1, up 2 over 1. Do not draw a line yet. Okay, from here, because it is less than, the sign is a less than. It's not equal to. Pac-Man doesn't have a chin. What would that look like if we graphed it on a number line? On a number line, Pac-Man had a chin, fill it in. If it didn't, what does it look like, Tanner? It was an open circle on a number line, so that would translate, have you done this before? To a dotted line. Cool. You might have seen that, but you're going to make a dotted line. If it's not a chin, don't fill the line in. If it's not a chin, don't fill the line in. Make a dotted line. This means that any point on this line does not work. So it has to be less than this line. You can't have a solution be 0, 3 because that's exactly on the line. That won't work for this inequality. Let's choose a point and test it out. Let's go x equals 0. You may be seeing a trick already that you can use without checking, and I'm going to get to that after this one. Wyatt, do you have the trick? Just kind of like the logical way. Okay, go ahead. Yeah. It's undefined. So when you have 0, 3, x is 0, it's less than 3. So anything here should be less than that point. You can look at the inequality and you can see that it says y is less than. So all of these points should be shaded in below here. All of these points work. So let's take out the shaded pencil and lightly shade in these sections. What does that actually mean? Well, it means any point that you want to choose on this part of the graph will work. Give a random point right now that's somewhere on here and write it in this first line. Silent hand, what point did you choose? You can choose 0, 0. You can choose 1, 0, you can choose 0, -1, any point. Choose some point on here, make a dot at that point. I'm going to start with 0, 0. So if you have 0, 0, the x is 0, y is 0. Let's see if it works. Test it out, and if it does work, it should make this inequality true. 2 times 0 plus 3. 0 would be less than 0 plus 3. 0 is less than 3. Is that true? Yeah, so that works. Give me another point, silent hands. Anywhere on here, there's like 30 to choose from. Felix. -2 down 5. Sure. If you throw it into your inequality, it'll be 5. Is it -5? Or did it do up 5? Did you do +5? Okay. Do you see the blender? So if we did 5, it would go up, and that's not going to be in the shaded. Can we change it to negative, Felix? Okay, let's try -5. -5 is less than, stop, 2 times -2 plus 3. -5 is less than -4 plus 3. Is -5 less than -1? Is -5 less than -1? Yeah, that works. So all of these solutions will work. What are two non-solutions? Any part, any point that's above the line, or any point on the line will not work. Let's choose 0, 3. Did you have that one? Did I steal yours? I'll come to you in the second one. So let's check on no solution for 0, 3. Plug in 3 for y. 0 for x. Is 3 less than 3? No. 3 is equal to 3, so you can't have a point on this line. That does not work. One more point. Tanner, what'd you put? 7. 7's going to be way up here, over 7, up 7. That actually might work. 1, 2. Yeah, 7, 7's going to work. That's a solution. Let's try -7, up 7. This point is not in the shaded area. It should not work. -7, 7. Check it really quickly. 7 is less than 2 times -7 plus 3. 7 is not less than -11. That does not work. Next page. When you have an equation not in y-intercept or slope-intercept form, you're going to change it. Y at talking 1. If you have 2x minus 3y is greater than 9, the goal is to get it in slope-intercept form. It should look something like this. Take your equation, and let's move some things around. I'm going to subtract 2x on both sides. The whole goal is to get the y by itself. Second step, what do I do from here, Andrew? Y is by itself. 2 over 3 are both negative, so it turns positive. 9 divided by -3 is -3. When you divide by a negative, what do you do when you graphed on a number line? Turn and talk to your partner. Go. In summary, what do you do on this one then? Brainstorm with your partner, and if you're confident, write what the sign would look like. Instead of greater than, what is the sign going to be, Kingston? Less than would work. Okay. From here, let's draw the line. Maya, where do I start? Okay. And what's my slope, Lexi? up 2 over 3, up 2 over 3. Is my line dotted or solid? Is my line dotted or solid? Does Pac-Man have a chin? Fill the circle in. Solid line. Sarah? It is not a chin, so I'm going to make a dotted line, extending this all the way up. Okay. If y is less than 2 over 3x minus 3, do I shade the top or the bottom? Thumb up or thumb down? If it's less than, what do you think it would be shaded? Top or bottom? Hands down. Wyatt, what do you think? Since it's less than, you're going to shade everything below this section. If you want to double check, Kieran, hands to yourself, face forwards. You can always throw in an x value that's on this line and just see what you get. Give me 2 solutions that would work for this. Kylie, give me 1 solution. Anything in this section will work. What's an ordered pair that would fall in this section? Does the 0.04 fall in this section? Let's choose that one. -4. 0, -4 would work. Kylie, give me another one. Over 1, down, how many? 1, -5 would work. There's like 30 options, maybe even more if you count the grids. A lot more actually, because that's 10, 20, 30, 40. It could be anything as long as it's going to go a negative number. I wouldn't choose like the point -100, because then you don't really know how far down unless you actually plug it in. But use one that you can visualize. Give me a non-solution for this, Mariah. Over 3, down 5. That's going to be close. Is that right on the line? -3, -5. Yeah, that's right on the line, and it's a dotted line, so that would work. And Addison, give me 1 other non-solution. Kieran, stop. That is a non-solution. Great. You have a page. Cool. Take out your appointment sheets. Keep your homework on your desk. I'll pick it up. Besides what? Yeah. I'll send it up with someone else. So this is something I forgot to tell you. When I say the number, they're gonna put 1 tally mark in the section that says the number of appointment. So when I say that number, just go ahead and put like a dash, like the blender board, so you can keep track of how many appointments you have. I did mine from yesterday. That's fine, yeah. Point to your 8 o'clock. If someone's absent, raise your hand. Well, then you and Colby can be together. 30 seconds, go. So I'm gonna have you, you're gonna put Tony and Felix for your Felix, you're gonna team with Jackson, and you guys will put 20. What's that? I don't have one. Cool, you don't have any. Hey, who's your 8? Who's your 8? Okay, you're with Colby right now. You're a team with 6. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Row 2 is at 100%. Row 3 is there. Cool. I'm going to pass out one. You're going to get your work you want to work on, or actually, I'm going to print out a Can you, Jordan, can you pass that over to everyone? And then I'll print out the tech test.